So the second section in chapter 5, what we're dealing with is centripetal acceleration. So centripetal acceleration, it depends on the speed v of the object and the radius r of the circular path. And that is illustrated in the equation centripetal acceleration equals the velocity squared over the radius. In dealing with direction, the centripetal acceleration of an object always points towards the center of the circle because it's moving around the circle. It continually changes direction as the object moves, as the velocity vector changes. So, another point, the centripetal acceleration is smaller when the radius is larger, and it makes sense because when the radius is in the denominator, anytime that number increases, the answer is a smaller number. As the acceleration approaches zero, when the r becomes very large. And uniform circular motion along the arc of an infinitely large circle entails zero acceleration. And it's a pretty good point because it's just like motion at a constant speed along a straight line if the circle is infinitely big. Now, conceptual example 4, uniform circular motion and equilibrium. A car moves at a constant speed along a straight line as it approaches a circular turn. In which of the following parts of the motion is the car in equilibrium? A, as it moves along the straight line towards the circular turn, B, as it is going around the turn, or C, as it moves away from the turn along a straight line. Now the correct answers are A and C because they deal with equilibrium, because B, as it's going around the turn, that has centripetal acceleration because even though it's at a constant speed, the velocity vector is changing, which entails centripetal acceleration. And the definition of equilibrium is constant everything, which means no acceleration. So the question you need to ask yourself is which answer entails zero centripetal acceleration, which is A and C. Now a couple check your understanding questions. Consider two people, one on Earth's surface at the equator and the other at the North Pole. Which has the larger centripetal acceleration? The correct answer that the book gives is the person on the equator because it moves in a larger circle, so that means it has the larger centripetal acceleration. The next, check your understanding. Which of the following statements about centripetal acceleration is true? A, an object moving at a constant velocity cannot have a centripetal acceleration, or B, an object moving at a constant speed may have a centripetal acceleration. The correct answer is B, because an object moving at a constant speed, as detailed in the first section, does not mean it has zero acceleration. There still may be a centripetal acceleration if the object is moving in a circle or is moving along a curve, where the velocity vector changes.